Hello guys, this is Daniel and today we are going to continue our series about blockchain programming with Python. We are going to create a script to deploy this Solidity contract that we have right here and deploy it through Brownie into our local Ganache environment. For that, we are going to do the following. So let's go to scripts, and we don't have anything here, so we're going to create it. First, we're going to start our virtual environment. So let's do our Python ritual. We are in our virtual environment, so let's do guest number, and here we are in the base directory of our project. Here we're going to create the script that we are going to use to deploy this contract. Let's call it scripts deploy guest number.py, and it's going to appear here. Let's go to that one and let's start. This is rather straightforward. It's very similar to what we did in the previous video using the console, but in this way that we're going to deploy the contract right now, we are not going to have the control session, so we are going to learn how to refer to a contract that is already deployed in a blockchain using the contract address, which is something much more reality-based to compare to what we were doing only using the console. As well, we are going to use a private key that we are going to take from our Ganache environment, which is also closer to what will happen in a production situation. So let's import the libraries that we will need. We will need import OS because the private key, we're going to keep it in an environment variable. And that means that we will need the .env, import load.env. And we are going to need to import the Brownie things. So we have to import Brownie. From Brownie, import accounts and the contract, which is called guest number. The contract was already compiled, but we are going to compile it again before running this little script here. Now, what we need to do to actually load this is that we need our load.env to load the content of our environment variables. And then when we have that, we define the main function, which is just def main. And to that one, we are going to add the following. We will need a deploy account, which is the account that we will use to deploy the contract. But for this, we are going to refer to this account through the private key. We could do it just by referring to the index in the account of the account as Ganache shows us. For example, here we have account 1, 0, 1, 2, 3. We could refer to the accounts by the index of the accounts, but that would not ask us for the private key, and it will be very easy. Later on when we do testing, we are going to refer to these accounts this way because that's a very straightforward way of doing it. But if we're in a production environment, most likely we need to refer to an actual address that exists in the Ethereum network. So that's what we are going to do right now. So we are going to create that one first. So we're going to do deploy account equal to accounts. And here we have a method that is called add. And we are going to add the account based on the private key. And that's the way this method works. But remember that we have that private key saved in an environment variable. So we're going to do it environ. And then we're going to call it as private key 1, referring to the index of the accounts. But this is not really necessary. This is totally arbitrary, depending on how you want to call it. So let's clear a bit this one, and we're going to start creating our environment variables. We're going to do touch, and we're going to do that emp, and that will give us this little file here. And here we're going to create that environment variable. So we're going to do a private key 1 equals and then we're going to copy the content of the private key, and that is going to be the following. We need to go to our Ganache to get that private key. So let's get it. We're going to get it from account 1, which is here, index 1. We're going to copy this one. We're done. Let's return to Visual Studio, and we copy that one here. So we have our private key. That's all the environment variables that we will need actually. So that's that part is done. Now we're going to do another part that we need to deploy the contract, which, as you remember, we need a dictionary that will tell the deployment script from which account we're sending the values, we're sending the deployment, and what is the value of the deployment, what is the amount of ETH that we are sending with that deployment. And this dictionary is going to contain the following values, the following keys and values. We're going to have from, and this from is going to be equal to the deploy account, which we are just creating according to our environment variable. And that's it. And the other part that we need is the value. So the value, we need the way, and this is a trick that Brownie offers us, similar to a functionality that we had in web.tree, as you remember in our previous series, that allows us to very easily just submit amounts of ETH as if they were text, and those will be translated to way at the moment of interacting with the network, because the network works in way. So we have those values there. Then we're going to do guess number, which is the deployment, is equal to the guess number object, which is the compile contract that we are going to get, and we are going to call it deploy, and we're going to say that the secret number is going to be 9, and then the other part that we need to send when we send this deployment is this dictionary that we created over here. So it's very easy, just deployment details. Now that we have that, let's do return guess number. So this script is going to create the actual contract deployed into our local Ganache network, and it will be created from the index account number 1, because that's the private key that we are sending over. Now we need to do something else, which is to compile the contract. So let's do Brownie compile. This was already compiled in the previous video, but let's do it again, just if anyone didn't have the time to watch it or forgot already. So we do guess number, that's all, and we compile the contract again. Nothing has changed because this contract is already compiled, and then we have it there. Now the only thing that we need to do is to run this script, and then this contract is going to be deployed to our local Ganache network. So we do Brownie run, and then we call the name of the script. We call deploy guess number .py, and we got our response back. So let's go back to Ganache, and we see that this account from which we sent the deployment has 10 ETH less, which is what cost to actually deploy our contract. Let's go to transactions, and we have the contract creation, and this is the contract address. This we actually we will need it later. So let's copy it, and let's go back to our Visual Studio Code. So now that we have the contract deployed, we are going to go to Brownie console. And now that we have the console there, let's do something. Let's do guess number. And we are in the same situation that we were in the video, in the previous video in the series, right? If we do guess number, and we try to call that guess number with the amount that we want here. So let's do guess number 0, which that should be the name of the deployment, and we do get balance. Then we get the list index out of range. And this is an issue that it's a little gotcha. You would have thought that you could do something like this, but it will tell you that that object, which is the compile contract, doesn't have that function, and actually it doesn't have it. The compile contract is just the ABI, it's just the ABI, but the actual contract is in the blockchain, and we don't have any reference to it right now. So something that comes very handy is the function dir, and then we're going to do guess number. This function gives us the methods of a given Python object. So let's do it. And here is where we are going to find the information that we were looking for. We have this at. We are just going to do guess number at. So number at, and we submit a contract address, which is what we have here. Brownie itself is telling us that a contract address goes here. Let's paste the contract address that we copy from our Ganache, and we send it. And it tells us that that number is actually, that contract is actually the one that it's in the blockchain and has some functionality. So we can interact with that one that way. So we can do guess number at, this is the deployment of the contract, and here we can get the functions that that contract has. Let's do the get balance, and we get the balance in way of the contract. And this way we can interact with this contract very easily. We could even try to play. Let's try to play. So instead of doing get balance, let's do play. And we are going to submit. Play takes two parameters. As we remember here, we have the guess number over here. So play takes two parameters. One is our guess for the secret number. Let's say that right now the secret number is 8, the one that we want to submit. And since we are here in the console, let's just, it asks also for the address. So let's do accounts. And we're going to do the first account as the one that's playing, and a address. And that one should give us the function play. So let's do it. Oh, it's here. Address, we have everything close. Accounts address, no, we're missing something, which is the dictionary of the values. So we need to send from, and this from is going to be accounts. The account 0 is the one that we're going to use. So let's say that this is the from, and the value that we're going to send is equal to 1 ether. That's the cost that we established for playing with this contract. So we're going to do 1 ether. We close our dictionary. That looks correct. We close our function, and let's try to play. It's giving us invalid syntax for some reason. Of course, this is a dictionary. Let's try to play again, and we got to call that function successfully. This guy play, which is the account 0, and let's go to our local Ganache, and let's go back to transactions, and here we have that transaction. It was a contract call with a value of 1 ether, and we go back to the accounts, and this guy play and lose 1 ether. That money went back to the contract. Let's go back to our Visual Studio Code, and let's try to play again. So right now, let's try to do it with our correct secret number, right? So let's do it from the account number. Let's do it from account number 2 and accounts 2. And we are going to play with the actual secret number that we choose. It was 9. I don't remember very well. Yeah, it was 9. So let's play again. We are here. Let's play again. And we submitted the transaction again. Let's go back to our local ganache. And as we can see in this table of the accounts, the account number 2, which is the third account, but it's the index number 2, that one got the balance of the contract, which was 11 ETH, one that this guy lost when he tried to play, and 10 that this guy invested for creating the contract. So guys, this is the way that we interact with our smart contracts using Brownie, and this is the way that we deploy them through actual scripts. So remember, this is very important. The actual object contract with which we can interact when we are in the same console session, and when we are in the same script, we can just refer to it as the index of the deployment, as we were doing before, right? In this fashion. But once we are not in the same script, once we are not in the same console session, then we actually need to refer to the contract in this fashion. Guest number, which is going to give us the ABI, and the ad, which is the address, and then that way we can call the functions. That's the way Brownie works. And as you remember from our Web3 series last week, there are 2 elements that we need to interact with any smart contract: the API and the address. Thank you very much, guys. If you like Python, if you like blockchain programming, follow this channel and smash that like with all that you have. Thank you very much. This is Daniel. Until the next video.